Okay, so we left off, we had just solved this. We went through the steps for substitution, solve for one variable, substitute into the other equation, simplify and solve for that variable that you have, and then solve for the second variable using your first expression you find, and then absolutely check your work. It will tell you if you're right or wrong immediately, so you don't have to go guessing if the homework, for example, is telling you have it wrong. So now we're going to look at some fractions. I know everyone's very excited to work with fractions. I do have a trick to make your lives easier when you're working with fractions, and that's to get rid of them. So we have negative 1/6, a 1/2, and a 1/2. So I'm going to multiply everything in this equation by a 6. I'm going to distribute that. 6 times negative 1/6 is just negative 1 with an x. 6 times 1/2 is just a 3 with a y. And 6 times 1/2 again is 3. For this one, I have a 1/3, a negative 1/6, and then let's make this, I believe yours is positive. I think I changed that. Make this a positive 3/4. So I'm going to multiply everything by their least common denominator, which is 12. So again, distributing to each. 12 times 1/3 is 4 with an x. 12 times negative 1/6 is going to be negative 2 with a y. And 12 times 3/4 is going to be 9, because the 4 and the 12 will cancel each other by 4, leaving 3 times 3. So this equals 9. And so now I have this new system that has no fractions. Now remember, just like we talked about in the last chapter, just because there are no fractions doesn't mean the answers won't have fractions. So we are going to be solving this using substitution. So our first is to solve one of these for its variable. Now I like number 1 here, the first equation, because it's already got the x. So coming over here, I'm going to add x to this side, subtract 3 to get x equals 3y minus 3. And then I'm going to plug this into my second equation here, 4x minus 2y equals 9. So I'm going to have 4 times 3y minus 3 minus 2y should equal 9. And now we, step number 3, simplify and solve. So we have 12y minus 12 minus 2y should equal 9. Add 12, add 12. 12y minus 2y is 10y. 12 plus 9 is 21. So y is 21 over 10. And then step 4, get the other variable by plugging it back into here. So x equals 3 times 21 over 10 minus 3. So this is 63 over 10 minus 3 times 10 over 10. So this is 63 minus 30, which is 33 over 10. So we are working under the assumption that our solution is 33 over 10, comma 21 over 10. Now before I box this up, I'm going to make sure I check my work. So we're going to do our check here. So the one thing that you do have to do is, we manipulated these equations to get to here. You need to check it in the original. And I know that seems horrible, but we do need to be able to check it in the original. You always check the original, because this is something you've done. So if you made a mistake going from here to here, it won't show up if you put it into here, but it will show up if you put it into these equations. So we have negative 1/6 for equation 1 times 33 over 10 plus 1/2 times 21 over 10 should equal 1/2. I can cancel a 3 out of this to make this negative 11 over 20 plus 21 over 20 should equal 1/2. Negative 11 plus 21 is 10. And that's definitely 1/2, so we're good there. So that was equation 1. Plugging into equation 2, we have 1/3 times 33 over 10 minus 1/6 times 21 over 10. And this should equal positive 3/4. So again, I can cancel a 3 here, make that 11. I can cancel a 3 here, make this 2, and make this 7. And then we have 11 over 10 minus 7 over 20 should equal 3/4. So multiplying by 2 here, we have 22 over 20 minus 7 over 20. And this gives us 15 over 20. And reducing that down by 5, we do indeed get 3/4. So our answer is correct. So I know there's a lot that goes into these problems. They're not particularly quick, and you want to make sure you're being careful. You don't drop a negative like I did, like I showed you in the previous problem. And you absolutely want to check your work to make sure you're doing it correctly, but always check in the original equations. Don't check in anything you did to them, because if you made a mistake to go from this to this, again, your mistake won't show up. And you'll be very, very frustrated when you check your work and it says you did it right, but the homework is telling you you did it wrong. So just like with the substitution method, we'll walk through the steps on this first example and then go through it a little bit quicker on the second one. So our first step for elimination is to match coefficients of one variable in each equation but we have the caveat that one needs to be negative and one needs to be positive. So what that means for us is we're looking at the coefficients, and in this case we have a negative x and a positive x, so we don't need to do any manipulation to these coefficients. But as we'll see in the next example, here none of our 4 coefficients match and none of them are opposite signs. So what we do is, once this is done, we add the equations. So now we have a positive x and a negative x, and when we add straight down, those cancel. And then we have negative 5y plus y gives us negative 4y, and negative 12 plus 4 gives us negative 8. And then once we've done that, we solve for the variable. So we're going to divide by negative 4, divide by negative 4. We're going to get y equals positive 2. And then number 4 is to substitute and check in both equations for the remaining variable, or the other variable. So this is, I said at the very beginning of this, or the beginning of this first video, that elimination is my personal favorite, is because we don't have to do the check and the solving part separately. Once you have one, we're going to go back to the original equations here, and we're going to plug this y into both. So in equation 1, we have x minus 5 times 2 should equal negative 12. And in equation 2, we have negative x plus 2 should equal 4. So by checking these simultaneously, we are verifying the solution at the same time, provided we don't make any mistake. Now you'll know if you've made a mistake if you get 2 different values here. So this is how we're doing that check at the same time. So we have x minus 10 should equal negative 12. Add 10, and we get x equals negative 2. So now if we've done this correct, either this part up here or this part, then the answer in our second check here will be negative 2 as well. Negative x equals subtracting 2 from both sides. Negative x equals 2, divide by negative 1, and we get x equals negative 2. So since we've got both of them, our check is complete, and our answer then is negative 2, 2. So elimination is slightly different. A lot of students tend to prefer elimination over substitution because it feels like less work. It's just a different kind of work. So this one seemed easy because we didn't have to do any manipulating here. But let's take a look at one where we have to do some work. So now in this one, we have a 3 and a 2, a 1/2 and a 1/3. We need to match our coefficients of one of these variables. Now, because these are fractions here, I kind of want to ignore them, and I want to just focus on the x's. So what I need to do is make this a positive number times x, and this that same number but negative times x. So since it's 3 and 2, I'm going to multiply the whole equation by a negative 2, and here I'm going to multiply the whole equation by a positive 3. So that's going to force this to be negative 6x, distributing here, here, and here. Negative 2 times 1/2 is negative y equals negative 4. And then this distributing to each of these. 3 times 2x will be a positive 6x. 3 times 1/3 will be a positive y. 3 times 5/3 will equal 5. So not every time is this going to work out so nicely where your number you multiply by to match the coefficients is going to match the others. Now this, once we add, 6x and negative 6x cancel, positive y and negative y cancel, and so we have 0 equals 1. And this is false. So remember, when we get a false equivalency, this means no solution, which means that this is an inconsistent system. So the last 4 are practice problems, where I'm asking you to solve by substitution and elimination. Now the practice in Canvas is going to be a little bit different on these because I want you to use the right solution method. So on the substitution, I'm going to be asking what you solved your variable for, and then what your solution was after that. For the elimination, I'm going to ask which variable you eliminated, and then for you to tell me what your equation was, like here at the end. So you need to be able to do both of these methods. Okay, so that's the end of 4.1.